Hello, and thank you for joining us at Chorus. My name is Hisako Shimizu, and I'm a process engineer at CrossMethod, Japan's leading cloud integrator with expertise in big data, mobile, and artificial intelligence. I'll be the host of this session. The title of this session is Empowering Pythonistas with DBT and Snowpark, and we'll be joined by Eda Johnson and Venkatesh Thakur. Eda Johnson is a principal data cloud architect at Snowflake, where she focuses on building industry solutions. Venkat is a data cloud architect at Snowflake, working with the industry, a solutions build team. Before we jump into things, some recommendations for making the best out of this session. All chat conversation is taking place in the Chorus Empowering Pythonistas channel of DBT Slack. If you are not a part of the chat, you have time to join right now. Visit getdbt.com community and search for Chorus Empowering Pythonistas when you enter the space. We encourage you to ask other attendees questions, make comments, or react at any point in the channel. After the session, the speakers will be available in the Slack channel to answer your question. However, we encourage you to ask questions at any point during the session. Let's get started. Over to you, Eder and Venkatesh.
Thank you. Hello, everyone. It's so exciting to be a part of Coalesce 2022 with a community of amazing people from all over the world. Welcome to our session, Empowering Pythonistas with DBT and Snowpark. Starting with introductions, I'm Eda Johnson, based in Austin, Texas. I'm a principal data cloud architect at Snowflake, and I lead a team that develops industry solutions jointly with our partners. On the left, here's a recent photo of me on top of Mauna Kea in Hawaii at 13,700 feet altitude above the clouds. Last but not least, I'm a huge fan of DBT, and I'm very happy to be a part of this amazing community.
Hello, I'm Venkat. I'm a data cloud architect, and I work along with Eda building industry solution here at Snowflake. I live in Waterloo, Canada. Here is the agenda for the session today. We start with some basics around Snowpark and Python, functionality provided by Snowflake. We then go into details about the newly introduced DBT Python models and how it works with respect to Snowflake. To see it in action, we'll present a cool demo around DBT, Snowpark, and Hex. Finally, we start off with our closing thoughts of what we had observed. With that, Eda, please give us some basics on your initial thoughts on the DBT Python models powered by Snowpark.
All right. Back in the Snowflake Summit in June of this year, Amy Chan from DBT Labs and I presented a DBT and Snowflake best practices session, where we started with why DBT on Snowflake is a very powerful technology stack. On top of all these differentiators we see on this exact slide we used, it's amazing that with the new DBT Python models, we're adding another reason: extended capabilities with Python. As part of the DBT 1.3 version release that was released only a few hours ago, now you can use DBT Python models with Snowpark. But what does this exactly mean to us analytics engineers? If you have been working with DBT for months or years, you might be thinking whether you should switch to new DBT Python models for transformations that you were previously doing in SQL. But this is really not the question we should be asking. We should rather be asking about the art of possibilities with DBT Python models that enhance the current data processing workflows. Python is a great programming language with many benefits, but what makes it very powerful is its rich ecosystem of open source packages. Just a few examples: GeoPandas is a Python package that makes working with geospatial data easier. Arrow package allows us to humanize dates and times with locales. The fuzz package is an extremely helpful package for fuzzy string matching. Phone numbers package is designed to parse and standardize phone numbers, including international phone numbers. And finally, Profit helps with the time series analysis. Even more exciting, there's a whole ecosystem of Python-based AI/ML packages and frameworks like scikit-learn and Keras. This is why we should be excited about DBT Python models with Snowpark. Let's take a closer look at Snowpark Python first. Venkat, can you tell us about Snowpark Python and how it works?
Yep. The Snowpark library provides an intuitive API for querying and processing data in a data pipeline. Using this library, you can build application that processes data in Snowflake without moving data to the system where your application code is run. With Python being one of the widely adopted language for data scientists, ML engineers, Snowpark Python brings the ability for modern data engineers and ML engineers to directly query and interact with Snowflake with their preferred language.
Python has a huge community of developers, but we often see people in community channels talking about challenges with Python. One big challenge is what's known as Python dependency hell, where managing dependencies between packages and multiple versions is painful. The other challenge is security concerns around using open source Python packages. Venkat, how does Snowpark and Python experience in Snowflake address these challenges?
Pip is the widely used tool for installing packages from the Python packaging index, also known as PyPy. Conda is a cross-platform package, an environment manager that installs and manages Conda packages from the Anaconda repository. Conda can install Python packages as well as the Python interpreter directly. When it comes to installing dependencies, pip installs them somewhat blindly and it does not validate much. If there was a potential version collision, etc., whereas with respect to Conda, these dependencies are validated uh, during each package installation. Thus, Conda facilitates a better dependency management. Anaconda has a vibrant community of enterprise customers who are adapting it as the de facto standard for the Python package management. Additionally, the libraries that are present in Snowflake Anaconda channel are validated for enterprise level security. Snowflake, as of today, has around 1,300 or so packages that can be imported. We are working with the Anaconda closely to add more and more packages based on the community interest. You can find these packages via the SQL command that we see on the screen. We are aware that we do not have every single Python package in our Snowflake Anaconda channel yet. In case you have one of those popular packages in mind that would benefit the community, please reach out to us via the Snowflake Community Ideas page and submit a request. As reflected in the screenshot here, the Snowflake Community's idea page helps us prioritize what packages should be part of the Snowflake Anaconda channel in the near future. Let's take a look at what happens when a Snowpark Python UDF runs under the hood. When a Snowpark Python is executed, it gets converted into SQL statements. If there is an UDF, that UDF would be compiled and stored in an internal stage as a bytecode. During execution, the serialized Python code will be unserialized and run in a secure Python sandbox within the Snowflake Data Cloud. The Python sandbox is secure and isolated, which runs leveraging Snowflake Compute. The code would not be able to connect to any services or ports to the outside world as external access is not allowed as of today. Also, the allocated file storage gets removed after the warehouse is stopped. Snowflake also recently announced the ability to execute Python code with richer implementation logic via stored procedures. These stored procedures work similarly to UDF as they run inside a secure sandbox. using Snowflake Compute. We can import third-party libraries from the Snowflake Anaconda channel via the package clause and additionally import custom libraries via the imports clause. These stored procedures are executed via the call statement.
Now let's take a look at how DBT works with Snowpark and other Snowflake Python constructs. Snowpark is designed to handle the following workloads we see on the screen, and it particularly shines at scalable and cost-effective transformations. Adding DBT Python models with Snowpark, along with capabilities DBT provides like data quality checks and CI/CD, now DBT Snowpark Python models can run in the same DBT DAG along with your DBT SQL models seamlessly. So how do DBT Python models work under the hood? With Snowpark, you write Python code in your DBT model, and DBT under the hood wraps your Python code in a stored procedure and executes it in Snowflake as part of your DBT DAG. Please note that you can choose to use permanent stored procedures or anonymous stored procedures to execute your DBT Python model. Anonymous stored procedures, which are still in private preview and soon to be in public preview, allow you to execute your Python code only once without creating a stored procedure construct in Snowflake, whereas permanent stored procedures will create or replace stored procedure object in Snowflake. With permanent stored procedure choice, you can also display the Python code DBT generates under the hood. If you have third-party dependencies, your code will access them securely using the Snowflake Anaconda channel. Or if they're not in the Snowflake Anaconda channel, you can upload them into an internal stage and access them using the imports parameter. Let's jump into the demo section, starting with a brief overview of an implementation, as well as the workflow we're following for a fictitious media and entertainment company. In this demo, we are analyzing customer behavior and identifying patterns that lead to churn. We are using 3 data sets. The first 2 are user data that contains user demographics and user subscription data that contains subscription history that is coming from a transactional system. Both of these data sets are generated for this demo to simulate a real-world example. The third data set, which is the Merkle customer profiles data, we were able to get with one click from Snowflake Marketplace. We were able to use over 25 columns like presence of children, homeowner status, and Merkle adjusted wealth rating to help us find meaningful signals that might influence the churn behavior. We also made sure that the generated user and subscription data sets match the customer IDs in the Merkle data set. A historical snapshot of the Merkle data we use for our demo has 32.6 million records. With this, we would like to demonstrate how we apply feature engineering steps like normalization, one-hot encoding, using Snowpark data frames, taking advantage of Snowflake's superior compute. These steps are traditionally done by data scientists using pandas data frames in their laptops, known as laptop ML, and it's typically challenging to process large data sets like this one locally. On the other hand, some of the other features we demonstrated include exploratory data analysis, known as EDA, and AutoML capabilities in a notebook interface, where we chose to use Hex. Hex has great integrations built in for Snowpark as well as DBT Cloud, and it also supports polyglot programming with Python and SQL in a single notebook. We also take a look at why we use DBT Python models with Snowpark and review 4 of the DBT Python models, where we also train an ML model in one of them. We are leveraging Snowflake's high memory virtual warehouses that are currently in private preview for this. ML training in DBT and Snowflake is still somewhat experimental, but we wanted to demonstrate what is possible. Last but not least, we will demonstrate ML batch scoring within one of the DBT models, where we also create a UDF for prediction. Let's see an overview of the workflow first. Here's a typical ML workflow we're simulating, where after ingesting data, we're doing EDA as well as iterative experimentation in Hex before we do feature engineering and model training. Let's take a quick look at the hex notebooks we used. Here's our EDA notebook that we use to understand our features and iteratively determine the feature engineering steps we use in DBT. Hex, which is a SaaS-based notebook product, is ideal for DBT Snowpark developers because Hex has handy integrations with Snowpark, as well as DBT Cloud. Hex also made collaboration very easy, as Venkat and I were collaboratively developing this demo. In this notebook, we first read the Snowflake table that has all the features as a Snowpark data frame and look at the columns that contain null values as well as numerical column statistics, such as standard deviation, average, min, and max values. We also look at how some features like presence of children, trial selection, and home ownership are correlated with the churn labels. Finally, we also look at the correlation matrix between features. So we make sure we don't incorporate features that are strongly correlated into our ML training. In another Hex notebook, our ML training development is done iteratively leveraging AutoGlow, which is an open source AutoML Python package. AutoGlow helps you execute AutoML experiments in 2-3 lines of code using different models and hyperparameters. As analytics engineers, AutoML was our friend here to confirm whether the XGBoost model, which we were originally leaning toward, is indeed a good choice for model training. As a result, AutoGlow displays the best models and hyperparameters for predicting churn with our data sets, as well as feature importance. As you can see, core Merkle adjusted wealth rating column or feature, which is part of the Merkle dataset, is the most important feature for our model. At the end of the experimentation, we start productionalizing the workflow in a DBT DAG that consists of SQL and Python models for feature engineering, model training, and deployment, as well as batch inference. After ML training, the model deployment in the same DBT model is generating a model artifact, a job lib file in our case, and saving it into an internal stage. Our main goal was to demonstrate the art of possibilities with DBT Python models, all in the same DAG. ML ops processes, which is a requirement for productionalization of this workflow, is mainly out of scope for this demo. However, we do capture some model training metrics and metadata, leveraging Snowflake's logging feature, which is currently in private preview. Now, let's take a first look at the simple DBT lineage graph, where we take 3 data sources and apply light transformations using DBT SQL models for staging and intermediate materializations, and then start using Python models, Python DBT models, for billing cycles aggregated table, as well as user encoded table. We will talk about the reasons why we decided to go with Python for these. The other 2 Python models we used in this project are to create a Snowflake table with train test data for model training and to predict churn as the new data comes in. Now, let's switch to DBT Cloud IDE to look at our DBT project, and particularly our 4 DBT Python models. We have run our project as a DBT production job several times successfully using a DBT job. We can see that in our run history. Now, let's go to develop in the DBT Cloud IDE and take a look at our project. Let's start with the intermediate subscription aggregation model first. We chose to use Python here because there are some non-Unicode HTML characters. These are bad characters that creep up in the source data from time to time for many of us that are in the subscription type column. And there's a handy Python package, fdfy, to remove those characters with one call. To clean up the bad characters in this column, we are creating an anonymous vectorized UDF to make a call to ftfy fixed text function. Vectorized UDF use here speeds up the execution tremendously as we're working with a large data set. After that, we're doing some aggregations using Snowpark data frame functions to calculate total amount paid, number of subscriptions, and total subscribed month fields for each customer, so we can use these new aggregate columns as features to predict churn. And we're returning the final data frame as a result of these transformations. In our DBT DAG, we also created another DBT Python model to apply one-hot encoding to some categorical attributes for our binary classification model to predict churn. In this DBT model, we're using a custom Python module, SP4PY, that is developed by a Snowflake principal sales engineer, Mats Stelvall, to use scikit-learn-like functions with Snowpark data frames. We uploaded a zip file with the custom Python code into a stage and specified the location of the zip in the dbt.config. After that, we use one-hot encoder class fit function to turn the 4 categorical columns like marital status into new binary columns in our transformed model. You can find this handy open source custom module, Python module that works with Snowpark data frames in github.com/snowflake-labs. Last, we create a train and test model by selecting the features we would like to leverage using scikit-learn's train test split function and run the training using XGBoost. We use a high memory warehouse for this memory-intensive operation with a larger data set and specify this in dbt.config. We take int users and subscription DBT model we created previously and turn the label column into a binary churn column first. Then we are applying the test train split and using the XGB classifier class from scikit-learn package to fit our model. We are also deploying the generated model artifact as a joblib file and saving it into an internal stage with a version. At the end of this DBT model, we create a single table materialization as a Snowpark data frame with train and test records by adding a new data set type column to identify each. Finally, in this DBT Python model, we're using Snowflake's logging to capture some model training metrics and metadata in a Snowflake event table. We can quickly see this table in Snowsight with all the features used for model training. It makes sense to incorporate dataset versioning in a production implementation so you continuously evaluate data drift over time. In this table materialization, you can see that we have a dataset type column indicating whether each record belongs to the train or test dataset as a result of the split. Last but not least, let's take a look at our last DBT Python model where we're creating a predict function using our deployed model artifact that was saved into our internal stage by the previous DBT model. Here, we're registering the predict UDF as a vectorized UDF, and vectorized UDFs are specifically designed to handle batch predictions efficiently. As the new data is ingested into Snowflake, using the UDF we registered, we're doing batch scoring to predict customers who will churn in this DBT model, and finally return a new data frame to be materialized with the predicted churn values. You can use vectorized UDFs in Snowflake with a vectorized decorator, or by simply using pandas data frames like we used in this demo. Now we can quickly see the materialization for this model in Snowsight as well. Notice the last column, churn predicted, is the predicted churn values for each customer as a result of batch scoring. This concludes the demo part. Venkat, let's share some of our thoughts with the DBT community before we close this session.
Yeah. Now we saw an interesting aspect on how the DBT model can be combined or embedded with traditional data analytics workflow. If we have scenarios like calculating mileage based on routing, or matrix multiplication or text similarity, or any other interesting use cases which require Python, you can use DBT Snowpark models. It'll be interesting to see how this roadmap evolves in the future. With the usage of Python, most of these data pipelines can be automated. However, not all activities are the same. Tasks such as exploratory data analysis and experimentation would still require some iterative and manual intervention. Hence, some level of coordination and handovers need to be done between DBT and data pipelines and other ML tools.
Before we close this session, we'd like to leave you with a couple of thoughts related to the new DBT Snowpark Python models. First, when it comes to Python, and specifically ML, organizations need to deal with both process and technology barriers to integrate ML workflows into their existing analytics data pipelines. To overcome the technology barriers, modern data stacks will need to evolve to support polyglot, just like how we demonstrated using Snowpark, DBT, and Hex. And we will see more capabilities, product integrations, and usability improvements to support this. We will also see more emphasis on collaboration between different personas, as well as the increasing role of AutoML tools, which will most likely be the go-to tools for analytics engineers. And last but not least, ML ops capabilities will be a game changer for productionalizing ML pipelines and being the last mile for breaking down silos between analytics and ML workflows. With that, we'd like to thank you for attending this session today. We will take questions in our Slack channel, and we're looking forward to interacting with everyone at Coalesce. And we hope that you all enjoy this wonderful event by DBT Labs.
Bye.
Okay, thank you for a great presentation. If you'd like to join the question and answer with our speakers, stay in the Coalesce Empowering Pythonistas channel on DBT Community Slack to submit your question and comments. If not, the next community session titled Extend a Long Way, a deep dive into data warehouse cost will be starting at 2:15 p.m. We also have introducing a DBT with Databricks starting at 2:10 p.m. CDT, and why metrics are even more valuable than you think they are with Lasco at 2:15 p.m. CDT. We hope to see you there. Bye. Thank you.